Okay, so I will share my screen. I have a presentation where we will be learning what EDIS is, just a graphical representation of it, and why we need EDIS, why it came into being. Okay, so all those things we will cover up. So EDIS stands for Enterprise Data Integration Services. So as you can see in the diagram below, it meant to create a central hub, okay, where all the information, enterprise information will be placed, and anyone who needs, when I say anyone, that is any application who needs the data, they can access it from the central hub. As you can see here, this is a point-to-point application connections where each application is connected to multiple applications to get the data. Whereas, we found some issues which we will be discussing in next slide. We found some issues in this sort of structure, so we wanted to migrate from this to the right hand side structure where all the information is stored into a central hub. Anyone who wants the information, any application who wants that information can connect to the central hub via adapter. We call the connections sort of adapters. Okay, and they can reformat the data as per their need, and then they can consume it from the central hub rather than going to the altogether to the other applications. Okay, and the data this EDIS will be storing is enterprise data. That is data which is used across the enterprise. Okay, so this is something which this slide will cover, like the basic background, the foundation and the engagement of EDIS, and some architecture. So the very first question is like why we need EDIS. So the diagram you are seeing as of now is represents the structure how different application in Albertsons interact. So as you can see, this is very complicated. This is tightly coupled. When I'm saying tightly coupled, each application is talking to a lot many other applications, and it is very difficult to identify like that which application is dependent on what other applications. So if I have to retire any of them, then it is a very big task, and to figure out the dependencies and all, and removing any application can it is error prone, so that if we miss out any connection, then there will be issue, the application won't be functioning as it should. So this was the issue with this point to point structure which we tried to solve with EDIS. Okay, so this is again the same similar thing, and these were the problem statements we had with this point to point. So it was tightly coupled, as I explained, tightly coupled, like there was too much dependency of application on each other. So if we try to move any of them, or any of the application fails, there is a high impact on all of the applications which are connected. Okay, and the second issue was more like multiple extracts of the same data. So let's say, as you can see in the diagram, this application one, okay, it is taking data from application 7. So maybe application 7 is passing on the same information to application 2 as well, application 3 as well, application 4 as well. Okay, so same data is being copied, is being sent from application 7 to different applications. To correlated, you can take an example of an employee. So maybe your employee ID is needed by another application of payroll. So the same employee database will be hit for the employee ID by payroll department. Again, your employee ID is also needed by your project thing. So your project application will again hit your employee database to get the employee ID. So the employee ID is being requested by a lot many applications. So the application 7 will be overwhelmed with the request for the same data. So that is not good. We are starving the application with too many requests. Okay. So this is another issue we found in point-to-point system. And to address those requests, the programs or jobs are also executing, which is killing the processing time of application 7. So that those were the issues with point to point. The other main issue was non-standard. When I say non-standard, that is like the format in which the applications need the data were different. Okay, so let's say application 1 needs the data in XML format, whereas application 2 may be needing the same information in a JSON format, and application 3 needs it in a flat file, okay, or a notepad file sort of a thing. So then, all those formats are different, and consuming them needs different sort of technical uh, programs or technical tools. So we want to standardize that too across the enterprise. So we want that all the applications should be consuming the same type of data, type of data format. It shouldn't be having all sort of colors with it. It should be standard. And the last issue we had with the why we implemented EDIS was that it was all undocumented. We were not having, as I showed you earlier, this is also not the complete picture. The things have changed over time. So, the application dependencies were not documented, and we were not aware exactly which applications are talking to what application. So that sort of structure was not present, and we wanted to document that too. So EDIS was the solution to all these problem statements. Okay, so like this was the solution we went with. This data hub is actually EDIS application. So it's from this sort of structure we wanted to transform ourselves into this one. This was just the calculation showing, if like you have 4 applications, then you will require 6 connections. If you have 8, the connections goes to 28, and if it is 16 applications, you need 128 connections. So how exponentially the connection increases. Whereas in this one, you can see single connection will serve all the purposes. So every application has to be connected to this data hub. Okay, and they can get the data from any other application they want, as it is bidirectional. I hope I'm clear. Any questions so far?
No, Hitesh.
Okay. So, this is how, EDIS is. So what in EDIS, we have different business objects. We call them business object diagrams, or board in short. So what a business object represent, it represents a logical entity. So when I say business object, let's say you have a business object. Again, I will take example of employee. So employee is a business object. So when I define an employee, an employee will have a lot many fields. Okay. So we define an employee. A definition of employee comprises of all the fields which are associated with it. So it will be like every employee will have an employee ID. They will have some designation. They will be having some branch location. They will be having some project to work on. They will be having a reporting manager. They will be having an address. So all these fields, employee ID, address, designation, reporting manager, branch, base branch. So all this defines that business object. Okay. So there's a person we call that associate as data modeler, who is responsible for defining that business object. Okay, so first of all, you identify a logical entity, then in detail you detail it out by putting all the corresponding uh, entries or attributes to it. Okay, all the corresponding fields to it. So you define, like just like a example, I defined an employee business object, and I defined all those fields which an employee should have. Okay, so this is what a business object is. Okay, now those data may be coming from different sources. For example, let's say you may be having a HR database in which your personal details are stored, your name, your address, and all those things. There's another database where here it is shown as, let's say, source 2, which is let's say your project database, where your reporting manager, your base branch, and the one you are working on are stored. So to get all the fields, it is not necessary that all the fields you will get from the same sources. So you may have different sources, different databases, different files from which those corresponding fields has to be populated from. So we have different sources for the to reflect the same one single business object. It could be two, could be three, it could be many. Okay. So this is how, in EDIS we define different business objects. Okay, and so a business object is sort of an entity in terms of which we can populate the data or we can consume the data from EDIS. Okay, so and a single business object can have multiple sources. Similarly, a business object can have multiple consumers too. So let's say your employee information, it could be needed by the transport department. They may need your address and your employee ID or want to bill you against. It may be required by the transport department, and at the same time the similar information, your employee information, may be needed by the payroll department as well, your designation, to calculate your VA. They need to know how long you are allocated to, so those things may be needed by the payroll department too. So there could be multiple consumers to the single business object as well. So there could be multiple sources, there could be multiple consumer too. Okay, but as you can see, these consumers, though they are multiple, they don't have to go to the sources all the way to different sources to collect different information. They can get it at the single point. So it is more like a single point of reservoir or single point of information for them. Okay, I hope this thing is clear to the team. So I will just give a minute to everyone so that they can read what we have here. So EDIS, as I already told you, it is Enterprise Data Integration Services. Okay, so it decouples the source and the target system. So it act as a mediator. EDIS act as a mediator between both of them. Okay, we follow a standard integration mechanism. This sort of mechanism which I have shown you earlier, it is called this Delta Hub. Okay, an RT system. This is standard. You can check it out. Okay, and it is we have a EDIS team who manage this data integration completely, which is us actually. Okay, the second thing is like when we define a business object, we are following. uh, yeah, was there a question from someone? Okay, I will continue. Okay, so we are following a message model. As I told you that we needed a standardized message format. So the message formats we have adopted is canonical message model. So canonical message model is a XML format as of now, in which we define a business object into we transform a business object into a canonical message. Okay, in XML format. We are in talks to migrate that into some other formats too, but that is something to for future. As of now, we are using XMLs to define a business object. We put all the entities into an XML, and we link them to the parent, and hence we define a business object using a canonical message model that is an XML. Okay, and we this is just an example of various departments. What goes through EDI, supply chain item, vendor master, the transactional data like purchase order, store order, invoices. So these are different business objects or different core functionalities which uh, EDIS deals with. Okay,
So
and
Hitesh, yeah. So Hitesh, this boards you saying it has all the data in XML format.
yes,
Okay. So if we are going to extract it, we need to consume that XML.
yes. So
Okay. Okay.
it's more like the sources you see, those could be a database or a file. But once we consume from these databases and files, we transform them into one XML of that particular business object. Okay, and then any consumers who wants that business object, they consume that particular XML. Okay.
So as a developer, is this our role to convert? I mean, where does we fit into this model, the diagram
Yeah.
you are?
Yes, I will. I have similar slides later on that will explain you better. But yeah, you are the one. Developers are the one who will transform, pick it from the all the way from source, and transform them into an XML. Those business rules and they automate those things. All those things are responsibility of a developer. Okay. Okay, this slide is talks more about from business and like how exactly when a business object requirements comes into picture, how exactly we transform it, but this is more for management, so we can skip it for now. It's like it's not needed as such for by us. It is more done by the uh, governance. Okay. And at the same time, whenever we define a business object, we have a portal, EDIS portal. It contains all the different business object, their corresponding sources, and the sample files, the mapping documents. We have a portal where we put it up, and anyone who wants those business object, they can go and refer that portal. Coming to the architecture, yeah, this is the thing which will be main for us. So as you can see, this black box is EDIS. I will let you know what goes inside. The left hand side where it is external slash internal, these are the sources. The one in amber, the one in which are to the right, those are the consumers. Okay, the one in green, and this black box is the EDIS. Okay, so in EDIS, major logical things which we do are sourcing, triggering, transforming, distributing, persisting them like persistence, and then consuming them by those are get consumed by a consumer actually. Sourcing is like taking it from the source. Okay, then triggering is like once you have all the data, then you trigger the things to extract the things, like you have a sourcing done, you have all the things in the locations you want, then you extract what you want. Okay, then you transform them. Okay, transform them as I said, it could be like a file or a database. You transform them into a XML. Okay, it is easily said than done, and there are a lot many things we do to transform it. Those There are a lot many business rules we implement. There are a lot many technical things we do. Okay, then we distribute them. Okay, we put it in various tools where one can consume from. Persistence is more like the data has to be persistent. Let's say someone wants the data of a day back, then they can have that should be persistent, that should be existent into the application somewhere. Okay, and then that particular data is being consumed by the consumers. Okay, so how exactly we do that is denoted by this thing. Okay, so we have external or internal sources. External sources are, by some third party. We may be receiving some data by some third parties. Okay, and those comes in the form of files mostly. Okay, and they can be sent to us. Okay, and like here you can see in the database could be also be there. Those are mostly internal things. Okay, so we have different application and their corresponding databases which resides into Albertson's ecosystem only. Okay, there could be some files which are coming from external. Okay, so what happens is like if I talk about in sourcing, we have this is how we implemented sourcing. Okay, we have a database, our own database, Oracle database. We call it RDS. Okay, so what we do is like we source the data into our RDS database via method called CDC, change data capture. So whatsoever are the changes into the source, we capture them and we put it into our own database. Okay, you will learn about it more in detail once we have more technical details from IIB and all. You will get to know that. Okay, similarly we have files. Files get transformed or maybe picked up from some FTP location, and those are being sourced into our own server. When I say own server, may not a database. It's more of a file location or a folder at our end. Okay, then there could be things which are coming from external. It is possible that instead of, so we don't keep a copy of it in our system, we directly trigger them, like we all directly take the copy and transform them into another thing. Okay, so this is a queue, a message queue. So we can consume the message directly into a queue, or either from the RDS, or maybe from from a file. We put it into a folder, and then then consume into a queue. So trigger it. Then once we have the message here into the queue, we trigger the transformation. Okay, we have a process to trigger that altogether. Then we parse the messages we received, maybe different sources, any source it could be. We once it comes into queue, it becomes standard for us. Then we will parse it up, enrich it. When I say enrich it, it could be the case that you may have employee ID, and the name is stored in some other location or some other database, and you can enrich the name by looking upon your employee ID. So you will run SQLs, you will do a lookup, you enhance that particular data. Okay, and you will create canonical. This is where the developer's main role will be, the transformation part. Okay. Once that message is transformed into canonical, which is XML as of now, okay, we will put it into a publisher flow. We put it to a topic. We send it to a topic so that it can be published to the world. When I'm saying world, it's like any consumer who has authority can keep it. Okay. In old world, like earlier on, what we were doing is, for persistence, we were having another database. We called it used to call it CDS. Now this is like, as you can see, this is dotted. This was meant to be retired. Now it is retired actually. So we were keeping a copy of the message. We put it on distribution for ourselves so that someone else can consume it. But now we have moved from this database to Kafka. Now Kafka has the ability to persist the data for for a while, based on the retention policy. So that persistence thing is being handled there. Okay. Then the last thing is the consumption thing, which is mostly done by the consumer. This is a consumption is a responsibility of a consumer. And again, the consumer could be an external party, internal system, the internal applications, or maybe some individual as such. This is the logical architecture with us. This is the tools, how we exactly doing them. So
Hitesh,
yeah.
Shalabh this side. Can you please give me some more idea on trigger event processing, like triggering how it is done?
Yeah, we have Java processes, and along with that, we do have ESQLs, which are stored procedure actually. So those we schedule those jobs, okay, maybe every 15 minutes or something, at at a frequency depending upon the business object. So those Java processes is running, which in turns, triggers those stored procedures, and then those stored procedures takes the data from the database and put it into a message set. And once you will be dealing with IIB sessions, you will get to know more about those things, and I'm sure developers will be taking them up in detail, how exactly we are
Yes,
doing that. Okay.
yes, it is. So, Shalom, we do have a detailed session for this one, triggering. So, where we're going to explain stored procedure and how they work and how they extracted it and put it on MQ.
Okay, Atul.
Okay. So this is the just the architecture, what we have discussed. This was more of a logical thing. This is how we implemented that thing. As I told you, we have a CDC thing, where from which we consume it into RDS. This is our Oracle RDS. Okay, so we from non-CDC, anything which is like, we have CDC change data capture. We have non-CDC, which are not change data capture. So mostly anything which involves the database will be a change data capture. So anything which has a timestamp, like all the records which are modified after a definite timestamp, we will capture them and put it into our own database, EDIS database. Okay. Non-CDCs are mostly files. Okay. So those are like files, or maybe at times, we are having some some programs which are putting into MQ, we are consuming from queues. So they put those messages in directly into our own queues. Kafka is another thing where they put the messages at times. Okay. and these are the different methods by which we take the message from the sources, consumes them into a queue, then we put it into this transformation system. Okay, this is mainly done by IIB as of now. Okay, we transform them and then put it into another Kafka topic from where consumer consumes it from. Okay, as of now, we have two Kafkas. One is placed on the cloud, one is on the in-premise on-premise server. So from on-premise server, we put a copy of the same message onto the cloud Kafka, and data science team is a consumer. Here, as you can see, this is a data science team. They consume it from that cloud Kafka. Okay, and at the same time, internal application, can consume it from our on-prem as well. Okay, and as I told you, the CDS and all those were the things which were uh, supposed to be retired. So now these are not there anymore. So we won't cover them as such. For old systems, we were in few of them we still have it, but yeah, as such it is retired. So we were consuming it from this particular Kafka topic, the XML, and we were putting it into a database of our own. Okay, based on the business object, we just store those information. So any application who want to see maybe 2 days back of data, then they can at least have that option available. Okay, and when you are transforming them, you do create audit logs and the message logs. We do store them into the message log as a audit requirement as of now. Okay.
Hitesh, I have a question. Why we are using two different Kafkas, like one cloud and another on premise? Like we can give access to our premise only, right? Is there some specific reason why we are doing this?
Actually, see, when we implemented Kafka originally, we kept it on-prem. Okay, and again, the reason why you don't want to, give access to on-prem, one is we want to filter it out, and it is more of a security thing as well. And we are moving on to Azure. So as of now, it is more sort of transformation we are doing. This came into be a picture later. Okay, so this was the existing thing. So designers decided to have a replicator which will replicate from on-prem to the cloud one, and it is more for security as of now, from as far as I know.
Okay, thank you.
Yeah. Okay. So this is the same thing. This just explains more in detail how exactly we are dealing with the message logs. As I told you, we have an audit thing as well in place. We have a message log which is constantly monitored by our support team. They keep on monitoring exception logs, and they get alerts, and all email alerts are being triggered. And based on them, they create incidents and all, and they take care. They make sure that we don't have any data loss. So let's say there are records which are being pushed in, and due to some XYZ reason, if IIB misses those records, or filter out those records due to some error or some validation failures, then those will be put into the exception logs, or and the audit logs will also be captured. Based on these two things, email alerts will be triggered, and the support team will either resolve them if they have the knowledge, or they will reach out to the uh, technical team. Okay, this is the tool set. Some of them uh, for different sourcing, triggering, transforming, and distributing. These are the different tool sets we are using as of now. Some have been merged into, like this persistent thing. As I told you earlier on, we were using Oracle to CDS database. Now we don't need this anymore because Kafka is the new tool we have used, and Kafka gives us that flexibility to store the data. It has a offset number which you can go back and go forward as well. So you can store data, you can go few records back, you can then go few records afterwards as well. So you can read past records as well, and you can then again go to the current position as well. So we have retired we are not using Oracle as such for the persistent thing. So these are the different tool sets. Axway is mostly used when we are getting files from some third parties, some external parties. So Xway is the tool to transfer them securely. Okay. Another mention which I should do is like that data for Oracle Golden Gate. When we say we are doing a CDC from this into our own database, we use a tool called Oracle Golden Gate. Here it is mentioned OGG in short, okay, which replicates the data from source into our own RDS database by capturing the changes. Okay, so these are different tools. Transforming is done by IIB in IBM Integration Bus. Okay, which is most of you will be developers will be working on. Any questions so far? Okay.
Looks good.
Thank you. Okay, so these are the core functionalities. So these are the small boxes you see. Actually, these are what business objects we have right now. Okay, so like manufacturer is a business object, vendor is another business object, wholesale customer is another business object. So these are different business objects. Okay, this whole lot of attributes which each business object possess. Okay, like store schematics. Store schematics is a business object in which you define which aisle should have what article stored. Okay, and what should be the size of it, where it should be placed into a store. So that is store schematics. Okay, similarly you have ASN, advanced shipping notice. Okay, so once from a warehouse, once the articles are shipped for a store, ASN is being sent from a warehouse to the store. So they send that ASN. So it has a lot many information on based on what exactly got being put up onto a truck or a fleet. Okay, so those things are being sent by ASN, advanced shipping notice. This is another business object, enterprise entity. Okay, we have customer. Customer is, I think, quite obvious for everyone. Okay, we have a cart, which is used for e-commerce. You add in just like in different e-commerce platforms, and we have a cart where we put our articles into, right? So those cart, the business object is there for cart as well, and it has all its attribute. Once you add an article, the item will be there, the item number will be there, their attributes, pricing and all those things gets added. So all those things are part of this particular, all those attributes are part of this particular business object. Okay, so these are being categorized into the core functionalities like supply chain, merchandising, store, consumer facing application, and few back office.
Hitesh, Shalabh this side. I have a question like supply chain, merchandising, store are these are the categories, and the blocks in green and orange are the business objects. So what do we call these blocks in blue color, like the party, planning, purchasing, product? These are functionality or what we call them?
These are more of just to group them up. We have grouped them like these are e-commerce things. So those are also consumer facing, and those are you can say these are the core functionality: supply chain, merchandising, store, consumer facing, and back office. Further, if you go to the sub level, then e-commerce, retail sales, loyalty, party, all these are customer facing. Okay, but yeah, uh, there's a subcategory to that too. So it's more like subgroup to it. The loyalty is
All it
like
is.
once you get rewards and all, right? Like if you go to some shop of yours which has a point system, so that is like your loyalty. They may be having reward system, they may be giving you special offers, they may be giving you coupons from time to time. Okay, so all this they must be having your profile saved. Okay, so these business objects fall under loyalty. So this is grouping we did. I hope I answered that.
Yes, I mean, so summarizing it, what I gave, like, I feel it like every business object will fall under some group, right? Like the multiple business object will fall under some group.
Yeah, yeah. because every
Okay.
business object will solve for sure, will solve some business purpose for, that's why it is there.
Right, right.
Because business object are created only on the request of business, like someone will come to you, EDIS team, that I want this information, and for sure there will be a question, why do you need that information? So they will tell us, okay, this information will be needed to solve this purpose, this business function, business purpose, and then only we will create it for them, once it is uh, complying to all the things we have, like it should be a enterprise data and all those things, and then we will create that uh, business object for them, and then it will solve some purpose for sure, so under some category. Okay.
Yeah, Hitesh, if on this side, yeah, what is the significance of these like store symmetrics and delivery? These are the same colors. So there is any relation between these, or what is the significance? They have the same colors.
The legend is here.
Is- Yeah, yes, yes. Is there any relation in between store symmetrics, delivery, and cart and shopping list?
Yeah, they were in progress when this particular presentation was being prepared. It
Okay,
was
okay. That is
it
the in
was
progress sign. Okay,
yeah, here's the legend.
okay, okay, okay. Got it.
Okay. Okay, then that is pretty much from my end, from functional end. Atul, or Pratyash, or anyone, in case you want to me to cover anything else specifically, any questions anyone
I
has?
think, yeah, I think we're almost like out of time now. So I think for today, I think we're good for this. And Pratyasha, the topic which you planned right today, so maybe like we can squeeze in that topic in next session. Okay, maybe tomorrow or Monday. Okay. Okay, then fine. I think we are good. If anyone has any question, we can talk about that. Otherwise, we can drop off. Okay. Okay, then before we drop off, right? So, Shalab and Rajesh, all five, right? So, new joinees. So, I will forward another meeting invite, which we always have at 1 o'clock, right? So, join that as well. Okay, I'm going to forward that after this meeting. And
Okay, Hitesh.
Prithvi to you as well. Yeah, sorry about you, Prithvi. I'm not like, okay, so I'll add you as well there, Prithvi.
Yeah, sure.
Okay, I think we can drop off. Thanks a lot, Hitesh. It was a nice session actually.
Thank you.
Okay, I'll share the video link after a couple of hours because it takes some time to uh, prepare that video and come back to us. So I'll share it with that everyone.
Okay.
Okay, guys. Thank you. Thanks a lot.
Okay. Thank you. Bye.
Thank you.